Hey, what's going on, guys? It's Courtney here with another video. Wanted to show you guys kind of another step into the threading video that I did before. So wanted to kind of show you guys what it looks like with threads communicating between each other, and kind of show you what what happens when you have any kind of delay in the processing path, and what happens with queues when they start to get backed up. Um, so I kind of wrote this. I'm not gonna say in a real world example, but I try to make it more of a focus example, like for networking devices. Just so maybe the concept or this might stick a little bit better. But the idea is I'm gonna have well, essentially four threads would be running all together, because you always have the Python main thread. What would happen is it's going to spawn three new threads, and each thread throughout the stage is going to have a specific task it's performing on the object, and then from there it'll pass it to the next thread via the queues, and at that point uh, it'll create the file. So we'll say start from thread 3. It initializes the node objects in memory, and then generates the hostname and management IP address. From there, I put a delayed time in there. We're just gonna say in processing time, that's 1 second. It'll add it to this queue here. Now, thread one, his job is gonna be processing the node object, and he's gonna be fetching the node type and setting the node type in that object, and then send it to thread two for processing. So what will happen is once thread one is finished, he'll every zero point 0.5 seconds he'll reach into the queue and grab an item, and then every 2 seconds, once he's finished doing what he's doing, he'll put that inside queue 12. And then from there, thread 2 will be going through and looping to get items out of the queue 1 2 every 3 seconds. Once he gets that, he's going to get the data and then save it to a file. It'll append to a file in the file system, and I'll show you guys what that looks like here in a second. So let's go ahead and look at some source code. So following the diagram, I'm going to try my best so we can follow the diagram here. Hopefully everybody can see everything. Can actually get rid of that. Alright, so and then I can let's do that there. Perfect. There should be enough space. Okay, so what we'll do here is we'll talk about kind of the package, the actual implementation from the beginning. So the packages that we're going to be using is the thread, and the queue package. Like I said, I'm going to be using time because that's going to be what's going to simulate my processing times as it goes through the actual cycle. And that's all important here. It's this other stuff that's not being used. I was experimenting, so you can ignore that. But the main packages that we're focusing on is going to be thread, queue, and then the time package. So first, we're going to go ahead and create our two queues here. So we have queue 13 and queue 12. That gets created there. Ignore that console because that's for formatting stuff, for printing on the screen. So just completely ignore that. You don't need any of that. So looking at the function. So the way threads work is that you have different ways that you can do it. I'm just going to deal with a raw thread. And what I'm going to do is I'm going to say each worker or each function will be assigned to a specific thread. So worker one will be assigned to thread 1. Worker 2 is going to be assigned to thread 2, and then worker 3 will be assigned to thread 3. So that's how that links up. And then we get down here into our main function, and we'll get into the logic here, but first we're going to show what happens when we start the script. We're going to run it. It's going to say main. It's going to run this main function. We're going to create our three threads. We're going to start our threads, and then we're going to join them, so that way we can get some parallel um, configurations or actions happening on it. So now in worker 3, we're going to start here in thread 3. Like I said, we're going to be initializing the node object. So I created this class here in the worker, and then I'm going to loop over 30 I'm going to iterate 30 times, and I'm going to create 30 node items. and then I'm gonna set the host name, which is just gonna be an increment +1, and then the IP address. It's just gonna be the in this subnet with the host incrementing here. And then we're going to say the node type is none because at this point we don't know what that is. So we'll print a message saying that worker 3 will be adding the host name for worker 1, and then we'll sleep for 1 second like we said, and then we'll put it inside the queue, which is Q13. Then we move up to worker 1, and worker 1 says, okay, well, while true, I'm going to get an item out of the queue. Once I get that item, I'm going to worker 1 got item 3. It's going to print that on the screen, and it's going to print that it's getting the node type. I'm going to set the node type here. I'm going to sleep for that 0.5 seconds, which that's going to emulate my pull. Even though I got it out the queue, actually, you know what? Let's move that out because I want that to stall before we get the item, not after. So, troubleshooting as I'm looking at it. So yeah, I want that to pause before we get the item. So actually, I did need to move that up. So after we do that, we'll do all our processing, and then during it as it goes, because I have the time intervals in, we're gonna see some backing up happening of the queues. So I want you guys to see that congestion. So we also have it saying where worker 1, he's gonna print the queue size of 13, the length of it, and then once he's done, he's gonna sleep for 1 second. Well, I'm gonna put it 2 seconds just to match the diagram here. I was doing some experimenting earlier. So we'll sleep for 2 seconds, and then we'll put the item inside Q12. And then we go to thread 2. He's going to start himself an infinite loop. He's going to say sleep for 3 seconds. Let's do 3 seconds. And then we're going to say worker 2's view size of Q12 is going to be the length of Q12. And then we're going to say worker 2 got worker 1's item of item hostname. And then we're going to open up this file called results.txt. We're going to say results.txt. And then we're going to append to that file the actual information out of the node object. And so this is all happening simultaneously between 3 threads. So let's go ahead and run the code and see what that looks like. So it might run a little fast. Once it runs, I'm only going to do 30 items, but we're going to go through the output so you guys can see kind of what's happening as the work is going on. So it's running through this process now. And give it a second. So once I see 30, so it's actually keeping up with the queue size. We got 14 backed up in one of the queues. So I'll show you what this all means once we're done here. Once it's done. So worker 3 should be finished. So worker 3 is finished. He's not putting any more items in the queue because he's gone through his iteration of 30 loops. So let's look here. And you see the queue size is eventually going down. And then eventually, once we finish processing all the workers, we should have this completed. It should be done soon. Now, one thing to keep in mind as well is that these are not priority queues. These are just basic first in, first out queues, FIFO queues. So there's no priority. There's no real order on how they're getting processed. Once the item is put inside the queue, his job is just to grab the item and then process it. So that's what we're doing there. And so we look like we're done. So even though you see the main program is still running, that's because the loops are still going. But right now it processed everything in the queue, and you notice that it processed, there it goes, 30 there. So let's see what happened. So let's start from the top. These are a lot. So as you can see, going through the steps, worker 3 adding R1 for worker 1. So worker 3 adding R1 to rotor 1. So it's adding it to the queue. And then worker 3 is adding R2 to the queue. So he's moving pretty quickly, right? So at this point, R1 is finally up, and he's like, oh, wait, I got something to do. So he got worker 3 item R1. So he grabbed item R1. He's getting the node type for R1. and then he's showing that the view of Q13 is 0. Worker R1 is adding R1 for ward 2, so he's adding R1 for worker 2, and then worker 3 adding R3 for worker 1, worker 2. So as you can see as it's going through, so as we start moving up, you start seeing the queue starting to back up, and that's when those delays are starting to come into play. So we get here, and worker 1's view of queue size 13 is at this point 7, right? That's because at this point, as he's offloading the information into the queue, he's putting more information into it. So he's getting a backup because he's pulling it quickly, but because he's putting everything in there slowly, when he puts everything at a lesser time interval, he's going to end up getting that backup. So you're starting to see that happening there, right? Now, once we look at the one for Q12, Q12 isn't really going to start seeing that much of a backup, but it starts to happen later on. Let's see with 12. Yeah, it's not going to be as dramatic because you're technically looking at 50% of time. Well, really 100% of time at that point. So, yeah. So it's not as dramatic in Q2 and Q1 too. But you get the idea. So now let's look at the file. Let's see if the file was created successfully. So we have my results. And look, as you can see, so it went through, it created all my objects, it went through, added it to the file, and it actually did it in order. So it actually ended up processing everything in order, which is good, even though the threads were working on them in random order. So once everything got joined, you actually ended up seeing this working and getting all your nodes created. But it's happening with within 3 different workers and 3 different threads. So that's kind of the cool things about the thread. So yeah, if you guys have any questions, if you guys want to see any more examples, let me know. But I kind of enjoyed writing this. This is really cool. So it'll be up on my. I'll have the source code up for you guys to go check it out. Let me know if you have any questions. Later.